Okay, this is exercise 1E again. We're looking now at the harder versions of finding the inverse of a 3 by 3 matrix. And basically they become harder when we chuck in an algebraic term. So for instance, rather than this saying, I don't know, 2, this could quite easily say 2a or something like that. So an algebraic term as part of it. It doesn't need to be any more than just one of them to make it a lot more complicated. So a little starter for us first of all. Can you have a go at doing those on your calculators, please? Doesn't matter what type of calculators. You need to be able to find the determinant of a calculator. So it's got a 3 by 3 matrix. And also the inverse. And I showed you the inverse button on the Cassia in lesson. It's usually written x to the minus 1. Obviously here it's there. Depends on which calculator you've got. If you've got the class whiz, it was in the middle somewhere around here. So have a look at that for me, and I shall then put the answer up, so you might want to pause the video. Okay, here's the answers, and what have we got? We've got 48, and we've got that rather big inverse matrix there. So let's just remind you then how we go about doing this without the calculator. We've got these steps to follow. The first thing is to find the determinant, and you may recall to do that you use the formula A1 plus little b, b1, plus little c, c1. And obviously, if the determinant is 0, then you can't find the inverse, because we've seen that what we do with it later was we have to divide by the determinant. So don't go any further than that. If your determinant is 0, just say there's no inverse. 2, then we find the matrix of cofactors, and that's all the A1s, the B1s, and the C1s, and the A2s, and the B, and so on. And once you've got those, you transpose the matrix to get the transposed matrix, and then you divide by the determinant, and that eventually will get you the inverse matrix. Now an example of this then is this inverse of this matrix. So let's just go through this. That's A1, I reckon, is minus 1, 2, or minus 5. So I reckon that's 5 minus 8, which is minus 3. B1, so this is just going across the top row. Now this is a minus. Don't forget the plus, minus, plus stuff. Minus, plus, minus, plus, minus, plus. They are important. And anyway, so if I'm doing that one, I get K2, minus 2, and minus 5. Hopefully you remember how to do this. But you'll notice there's a K in there now. That's the algebraic bit I was referring to. So this is minus 5k in the bracket, minus, what have I got? Minus 4. So I reckon it's minus 5k plus 4. Notice there's a minus at the front. So I reckon it's 5k minus 4. And now C1 is what we got with there. So it's equal to k minus 1, minus 2, and 4. It gives me 4k. That's plus 2, and multiply minus 2. That's given me the top row. I did say find the determinant, so I should really just check that. Now we don't know what the value of k is, so in the question it may well say something about that, but for now I'm not going to be too fussed. But anyway, the determinant of a equals 1 times by minus 3 plus minus 2 times by 5k minus 4 plus 3 times by 4k minus 2. And if I just work it out, I get minus 3 minus 10k, minus times the minus is a plus 8 plus 12k minus 6. And if I just play around the k's, I get 2k. And I get minus 3 minus 6 is minus 9, I reckon minus 1. Now obviously if k was equal to a half, I'd have a problem. So I'm going to assume that k is not equal to a half, so I can carry on doing what I'm doing. So I've got the A1, B1, C1, and now I need to switch to the A2. What's the A2 equal? That's this one here. So that's a minus, don't forget. Minus 2, 3, 4, and minus 5. That is a minus 10 minus 12. That's minus 2, I reckon that's 2. A2, B2, This is a plus. B2 is 1, 3, minus 2, minus 5. That's minus 5, minus that minus 6. So that's a plus 6, I reckon that's 1. And C2 is a minus again. And what numbers are there? If I put it there, I get those. 1, minus 2, minus 2 and 4. You're very careful on these minus ones. 4, minus, put it in bracket. That's 4 when I do it. Well, 4 minus 4 is 0, so even minus will make it a 0. And then, of course, I've got the A3, the B3, and the C3 to find. And the A3 is from there, I get that one, it's a plus, so it's minus 2, 3, minus 1, 2. It's minus 4, minus and minus 3, which is a plus 3, I reckon minus 1. B3, this is the minus version of it. And that's 1, 3, K2, which is minus 2 minus 3K, which is the same as 3K minus 2. And last but not least, I've got from down here, I've got 1 minus 2K and minus 1. And that's minus K, and it is a plus version, so I don't need to worry about that. It's minus 1, sorry, minus and minus 2K. That's plus 2K minus the 1. So now my matrix of cofactors, don't know where I'm going to write this because I'm sure I've got answers underneath here somewhere, is minus 3, 5K minus 4, 4K minus 2. I've got 2, 1 and 0. I've got 1, 3K minus 2 and 2K minus 1. I'm going to transpose it. That's my MT. Minus 3, 2, 1. I've got 5K minus 4. And 1, 3K minus 2. Don't mind how you do this, whether you just think it as reflecting or rows and columns swapping round. What's my last one? My last one is 4K minus 2, 0 and 2K minus 1. And therefore my M inverse, in fact I'm too lazy to write it there, I'm going to write it here, M inverse is that, and I've got to divide it, so it's 1 over 2K minus 1. And that's my M inverse. Where's my answer going to go? Or I'm just trying to see this underneath this now, 5K minus 1, 3K minus 2, 4K minus 2, and that unbelievably is perfect. So, and I have previously said I've checked that answer, so it does work, so I'm happy with that. Now we've got 3 for you to do. I mean, I suspect I'm going to not do them all. I might do 1 or 2 of them in class just to remind you, and that will probably be a good way to start the next lesson. But again, what we're doing, in fact, I'll just try to do 1. What I will suggest you do is then you do 2 and 3, and I will give you the answers before we finish. Okay, so hopefully then you'll get the right answer. Interestingly, this one is AB to the minus 1, AB inverse, but they tell me what AB is. The fact it's got 2 letters doesn't really matter, it's just called AB. In actual fact, I think the question they multiplied 2 together first of all and then said find the inverse of AB. But either way, here goes. So I'm going to find A1. I don't know why we always those letters, but yeah, that's what they often have in exams, obviously. So A1 is, I'm going to do exactly the same as I did before. 3, 1, 1A. So I'm not bothering about number 2, and I'm not bothering about number 3. That's for you to do when I've finished this, a little bit of extra work before you come to the lesson, perhaps. Unless I do this very quickly, of course. 3A minus 1. A2. Oh, sorry, B1. Let's do that first. That's what I did last time. So it's a minus, and it's a 0, 1, 1A. Now, what that times that is 0, so it's minus 0, minus a 1, which is minus 1, but it's plus 1. And I've got to do C1 as well. And C1 now is back to pluses, and it's 0, 3, 1, 1. I like these numbers, they're really nice. Obviously they felt sorry for the people that year. That's 0, take away 3 is minus 3. So that's the A1, B1, C1. So now we'll switch to A2, B2, C2, but not before really. I suppose I want to find the determinant. Let's do that now whilst I can. To find the determinant, you just take the 2, and you go 2 times by 3a minus 1, plus the minus 1, times by the 1, plus this 1, times by the minus 3. So what's that give me? Give me 6a minus 2, minus 1, minus 3. So I reckon that's 6a minus 6. And again, this would be singular if a was equal to 1. But as long as it's not equal to 1, then we can find the inverse. And I'm sure in the exam question somewhere it would have mentioned the idea of singularity as well. So A2, let's go on to that. I've got a negative 1, remember. And it's minus 1, 1, 1a. Hopefully you're good at these now. So it's minus a, minus a 1. So I reckon there's a plus 1. B2, this is a plus version, so this is 2, 1, 1a. If I do that, I get 2a minus 1. And C2, this is a minus 1. So it's 2, 1, 1. Yeah, so I was just checking I did the last one right. 2 minus 1, 1, 1. That's minus version of 2 minus minus 1. That's 3, but therefore it's minus 3. And finally I'll get and do the A3, B3, and C3. A3 is plus to start with, and therefore I've got minus 1, 1, 3, 1. Which gives me minus 1 and minus a 3, which is minus 4. That comes a minus version, and that's 2, 1, 0, 1. And that gives me a minus 2 minus nothing, which is 2, which is minus 2. And then my last one's a plus version. And what have I got on this? I've got 2 minus 1, 0 and 3. And I think that's equal to 6. So, matrix of cofactors is 3a minus 1, 1 minus 3, a plus 1, 2a minus 1, and minus 3, and minus 4, minus 2, and 6. And we've already seen, therefore, that if I transpose it and divide by the determinant at the same time, this will work. So there's my divide by the determinant, and now I just want to transpose this matrix. 3a minus 1, a plus 1, and minus 4. 1, 2a minus 1, minus 2, minus 3, minus 3, and 6. I think that's the right answer. I have no idea if it is. So I'm just going to rub out loads of stuff on this, so then hopefully I will then be able to see the answer underneath. I think the answers come up underneath it, so probably I can get away with just doing that. So let's go back to my pen. And answer, there it is. Well, you can't quite see it. It says 1 over delta, and that delta is the discriminant. This is a Greek letter, delta. And it says 6a minus 6, so that's right. 3a minus 1, a plus 1 minus 4, 1, 2a minus 1 minus 2, minus 3 minus 1. You can't see these bottom ones, but that is right. So what I will do now is I will delete everything on the slide. You can then just about make out that perhaps. And I want you to have a go at doing these if possible at home. If not, I've got one question I've saved for you for lesson, and that will do. So best of luck with that. It's quite tricky, but worth it if you suss it. Well done.